Okay, so today we're going to talk about the loss function, or why it's a good idea to run the target. And the loss function is a way of managing, let's say, a process. It's an alternate way of looking at, uh, some kind of output versus, let's say, the specification approach. So, for example, you have a specification, down here. Just do this for an example. You have kind of this region of what's called no loss, and it's usually defined by some kind of a, lower or upper specification limit. And basically, what it's saying is that, as long as anything is in between these two limits here within this region, everything is okay. And this approach has been around for a very, very long time. It's you know generally easy to understand, easy to use. And for most processes, as long as the specification limits are well thought out, it's actually, not a bad way to go. The problem is when, you're starting to maybe match up items. This is where, an example of where you can get into trouble. So, for example, let's say, I'm measuring something and, I get a measurement down here, and then I measure another item and I get the next measurement here. The specification approach says basically, well, these two items are the same from the standpoint of being, okay. Now, this can be a problem if, let's say, you have two components that need to be matched up. So, for example, let's say, I'm building windows for a home builder. Okay, and all my dimensions are at the low end here for those windows. And let's say I'm a home builder and I'm building openings in the house, and all my specifications for that opening or those dimensions are at the upper end. So this could be a problem when those two products come together, because the fit may not be as good as you would like it to be, versus trying to run to some kind of target, or being more consistent. So this is where the loss function comes into play. And really what it's saying is you just have a target, okay? Pretty much just a kind of a target region or a target area. And it's saying that as you move away from this target, okay, you're incurring some kind of loss. Now, this loss can, be monetary, or it can be some kind of increased risk or something like that. And that loss is actually determined usually by some kind of function. So here we have this, kind of curvy line here. This is what's called a quadratic function. And basically the way it works is it's saying that as you're moving away from target, you're not just increasing your loss in kind of a linear way. It's actually getting worse and worse fairly quickly. Okay. So this is kind of the loss function approach. It's not necessarily a shop tool or a shop floor type tool. It's a little bit, I would say, a little bit more difficult to understand maybe mathematically, but conceptually I think it's a lot more realistic of a lot of situations. Okay. Let's give an example. Let's say you're in food manufacturing. Okay. And if you package a product, you typically want that product to be in your consumer's hands, as soon as it's been packaged. So you can imagine, let's say, having, some, time here, and you're manufacturing, your packaging at time equals, let's say, 0, and then usually there's a pull date out here of some kind, a limit. But the specification approach would say, well, everything's fine, in terms of, let's say, some kind of staling factor, and then on the last day it goes completely bad. But the reality is, as soon as you package, there's kind of a staling that goes on over time, so this product, is lesser here than maybe over here. So again, the specification approach kind of limits you here. It's giving you a false sense of maybe security, where the loss function approach, says, hey, listen, we really have to optimize our distribution system to make sure this product gets out as quickly as possible. Another good example would be, if you're, going out and having beers or something like that, and you want to be careful about drinking and driving. Well, there's a legal limit here, okay, for intoxication, but the fact of the matter is, impairment starts as soon as you start to have those first drinks. Okay, so really the strategy there is, if you're drinking, don't be driving, and if you're driving, have 0 drinks, because really you're not going to wait till this upper limit here and think you're going to be safe, anywhere in this region, because you're definitely going to be impaired. So that's kind of the comparison between the loss function and the specification approach. There is a measure for the loss function. It is called CPM. And the way CPM works, it's basically taking the upper and lower spec limits. So, even on this loss function, you might have some limits for a range here, divided by 6 times tau. So tau here is equal to the square root of the process variability, okay, here, and this off-target distance. So this is the loss function piece here. So x bar is your process average, and you can see that if your process is on target, this term will go to 0. If it's not on target, you can see that this squared term will definitely increase this value quite a bit. So again, when it's on target, this goes to 0, and then all you're left with is the process variability, which you need to reduce. Now, if the math is a little bit complicated, or if you don't really want to get into the quadratic functions and all that kind of stuff there, all you have to really remember is there's 2 things to look at. One is to run to target and reduce variation around that target as well. So, keep that in mind. So the difference again is specification says, run the spec, anywhere in between this range is perfectly fine. Okay, there's, no loss anywhere in here, and the loss function says, okay, really there's just a target range, and the farther away we get from that target, the worse things are going to be. That's kind of the basic rundown of the loss function. There's different types of loss functions out there. Some don't have this quadratic feature here. Some have different types of loss functions that dictate when the loss is going to happen, and there's quite a few resources out there to read about that. But again, basically it's about running to target, reducing variability, and hope this helps, and we'll talk to you again.